Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
One of the 7 millennium problems of mathematics is to prove or give a counter-example of this statement, open quote, in 3 space dimensions and time, given an initial velocity field, there exists a vector velocity and a scalar pressure field, which are both smooth and globally defined, that solve the Navier-Stokes equations. End quote. $1 million will be given to the first person to prove that statement. In mathematical physics textbooks dealing with the subject of multiphase fluids flowing across a porous medium, the partial derivative terms on the left-hand side of the partial differential equations that I described are non-zero. Those mathematical terms encoded both the temporal and the convective acceleration forces. By the definition of the word inertia as the tendency of fluids in motion to remain in motion, those two inertial forces exist whenever and wherever any fluid is in motion. Yet, those two forces were erroneously zeroed in every mathematical physics textbooks on porous media flows. My contribution to mathematics that was the cover stories of top mathematics publications is this. I discovered that those egregious mathematical errors were coded and transferred into supercomputers and communicated across a tightly coupled ensemble of millions upon millions of processors that defines and outlines the modern supercomputer. In expanded form, for 3-phase, 3-dimensional fluid flows, those temporal and convective inertial terms corresponded to the 36 partial derivative terms that I invented and added to the 45 partial derivative terms that were described in mathematical physics textbooks that dealt with petroleum reservoir simulation. My contribution to mathematics is this. I extended the borders of mathematical knowledge, and I did so by a distance of 36 partial derivative terms that encoded the fluid dynamical processes at a distance of 1 mile beneath the surface of the earth. The massively parallel supercomputer that I discovered to be faster than the vector supercomputer communicated across its central processing units, and therefore was not a computer per se. It was a quote-unquote virtual supercomputer that was shortened to and renamed as a supercomputer. I was in the news headlines back in 1989 because I discovered how to compute and communicate and how to do both across that virtual supercomputer that I visualized as a new internet de facto. That discovery of practical parallel supercomputing was how I redefined the boundary of what a new internet can communicate, and redefined that boundary of human knowledge by a factor of 65,536. That discovery of the practical parallel supercomputer pushed the frontier of the internet technology, and did so because it is a theoretical discovery of the internet and an idealized model of a planetary supercomputer hopeful that is a new internet. That new internet is a new global network of billions of computers. The new supercomputer that I experimentally parallel processed through is a new global network of 65,536 central processing units that I visualized as equal distances apart and on the surface of a hyperglobe embedded inside a 16-dimensional hyperspace. I used the word internet in this manner because I prefer that the technology define the name rather than the name define the technology.
Insightful and brilliant lecture.